Good morning, good afternoon, or good evening to everyone. Dear invited authors and guests, it is my pleasure to welcome you to the 6th International Congress on Information and Communication Technology through Zoom on behalf of ICICT 2021 and Global Knowledge Research Foundation. As every one of us is passing through these unforeseen circumstances with COVID-19, we wish everyone and their families a safe time, and we all hope to pass through this together soon. Further, with immense happiness, I'd like to share that we have received an overwhelming response this year from across 90 countries, where 1,000 papers were received and 350 papers were accepted, contributing to the success of this conference, and the papers will be published in 4 volumes this year. We are all thankful to our guests present on this platform who join us digitally for this conference in these unpredictable times. I'd like you to welcome to the technical session number 7 and further introduce the chair for this session, Gabriela Marin Ravantos. So Gabriela received a master's in computer science from Case Western Reserve University in 1985 and a PhD in business analysis and research from Texas A&M University, USA in 1993. She has been a computer science faculty member in Costa Rica since 1980. She was Dean of Graduate Studies and Director of the Research Center for Communication and Information Technologies, both at UCR. Currently, she is the Director of the Graduate Program in Computer Science and Information. From 2012 to 2016, she was President of the Latin America Center for Computer Studies, becoming the first woman to occupy such a distinguished position. Since 2016, she is Vice President of the International Federation for Information Processing, in charge of the Digital Equity Committee. Her research interests include smart cities, human-computer interaction, decision support systems, gender and IT, and digital equity. Welcome, Gabriela.
Thank you very much. It's a long presentation. For short presentations I will do from the presenters. I'm really glad to be here. For me, it's a pleasure to hear from some research being done in Asia and some in the US. Latin America is trying to join the research community, and I'm really glad that we have almost gender equality. We have 3 women presenters and 4 men presenters. That's a really high percentage of female presenters. I would like to welcome you. There are some really strict rules. You have 12 minutes to do your presentation, and then we will have 3 minutes to do some questioning to the presenters. So we are really tight. We will have 7 presentations in such a short period. And so I will be asking you to be very careful about your time. In fact, our moderator will tell you 2 minutes ahead when you're almost done. So please take care of the timing. I would like to find out if we have the first presenter. She is from Iraq, sorry. She's Iman Amer Hamid Al-Daha. I'm sorry if I pronounce it completely wrong. She's from the University of Baghdad. Are you here? It seems that she hasn't arrived yet. So we can try to go ahead and introduce the second presenter. She's also a woman. I hope she's here. Are you here? Seems that she's not here either. So we'll go.
Sorry, Chair. I will be the presenter for this paper instead of Dr. Sang.
Ah, okay. Can you present yourself?
Yeah, okay. So can I start?
Yeah, sure.
Okay. Let me share my screen.
Mhm.
Okay. So good afternoon, ladies and gentlemen. My name's Trần Đức Duy, and today I'm going to talk about the paper named Sentiment Analysis of Movie Review using Machine Learning Techniques. And the purpose of this talk would try to compare some method for classifying a comment into a positive or negative class. So before we jump into the presentation, I would like to share my deep gratitude and appreciation to Dr. Nguyễn Thị Thanh Sang and Dr. Đào Trần Hoàng Châu, who encouraged me and helped me a lot to complete this research. Okay, let's start with the presentation. So I divide my presentation into 4 main sections. First of all, I will talk about the advantages of the sentiment analysis and then explain the core NLP model that we used in this project. The next, we will talk about how to build a model for classification and the machine learning method that we apply. The third part, we will show you the result, and the last is the conclusion. So if you have any question, please save it at the end of my presentation. Okay, let's start with the first part. What is sentiment analysis? So this is the process of the computationally identifying and categorizing opinions from a piece of text and determine the writer attitude toward or the product, the service is positive, negative, or maybe neutral. In short, sentiment analysis help the company point out the public thoughts and feelings about their products by the feedbacks and online conversations. So in this project, we implement all the method by using Java language with NetBeans and some libraries such as the Workout library, Workout Deep Learning for J and Stanford Core NLP. And I will show you the background Core NLP model. It is created by the Stanford University. The model was made from over 11,000 sentences from Rotten Tomatoes, and they assigned the labels for over 200,000 phrases in this model. So now let's consider the sentence. You'll probably love it in the trend set of Core NLP model. So we can see that the score of each word, phrases, and the whole sentence were ranged in the range from 0 to 4, which 0 is very negative, 1 is negative, 2 is neutral, 3 is positive, and 4 is very positive. So we can see that the Stanford team does not only consider the word or the phrase, they take care of the structure of the sentence. They do not eliminate any word in a sentence, even the period. So how can Core NLP work look like? What is right this figure? The annotation object here will receive and store the input text. I mean the comment as a map in Java, and then it will transfer the data through these annotators. For text analysis, and the annotator will read, analysis, and send back the result to the annotation. If you want to do the sentiment test, we must go through all the annotator here, respectively. If we change the other after execution flow, the result will be incorrect. So now let's turn to the second part. That's about the machine learning method that we use in this research. We apply the decision tree, naive Bayes, recurrent neural network, blending, voting, and all the method require the input text in ARF format. So to convert the text file to ARF format, we use the symbol COI in Workout. And here you can see this is the Core NLP trend set in ARF format with all sentence and the class. Okay. For building any classification, we all have 3 basic steps. The first is the pre-processing. It means that we will convert the comment from natural language to computer language by vectorizing and then reduce the size or cleansing data. The second is apply the algorithm to build a classification model. And the final step is evaluation model by using tenfold cross-validation. So now we will go to the detail of each model. At the processing, we apply the string to word vector filter to convert the string attribute, that means the word, into a set of numeric attribute representing for the word occurrence. To calculate the word occurrence, we are using the TF and IDF method to reflect how important a word in a collection. It means that if the word appears in every sentence, so they have no meaning for classification, and we use the stop handler, it looks like a dictionary contains some meaningless for classification word, such as the word and the MSR, yeah, and etc. With lowercase and output word count, it's mean for the minimize the data set. So like we said before, the pre-processing data, which aim to cleansing data and just keep the important word for the next step. After cleansing data, we will move to the building model. We choose the most popular algorithms to build a classification model here. They are the season tree, naive Bayes, and spot vector machine. And then we apply tenfold cross-validation to evaluate the model in the test set. So as we can see, that's very simple framework with a single algorithm for building model. Now we'll move to the more complicated model. It's a framework of blending. It still has the same pre-processing data like a simple one, but in a step building model, it's required more than one algorithm, or we can say as example algorithm. It has some submodel here, like the season tree logistic regression support vector machine. And this base model will generate the output, their predictions, and those output of the base model will be the input of the meta classifier. Here is the naive Bayes. And the meta classifier will learn how to best combine the prediction from the submodel and then generate the final prediction. And after that, again, we apply the tenfold cross-validation to evaluate the result. Which voting framework still has the same pre-processing like single one, but at a step building model, it includes 3 submodels. And each of the submodel will make their prediction, and voting will choose the majority of them. This means that if 2 submodels say positive, voting result will be positive. And the reason why we choose 3 models here, 3 submodel here, because the decision tree yield the best result for positive, while the other one yield the best result for negative. Then we evaluate the tenfold cross-validation. Now we move to the new framework. It's an RNN framework. The pre-processing will be more complex and take more time than other framework before. The text will go through 3 filters, which are instant iterator, layout specification, and neural network configuration for cleansing data. The first filter, instant iterator, it means that for the word embedding used for information retrieval task, and the rest of 2 layers means that the text analysis keep or eliminate the information. Then we apply RNN method for building model, and again use the tenfold cross-validation to evaluate the model. So now turn to the next part. This is experimental results. So we have 2 different data sets. They are co-NLP with 800 comment and movie review dataset with 800 comment. We divide this dataset into trend set and test set. Trend set contain 600 comment, 300 for negative and 300 for positive. Test set contains 200 with 100 for positive and 100 for negative. So here, we can see the difference between two data sets. A comment in a QNLB database just
sorry to interrupt. Just a reminder, you have 2 minutes left before questions.
Okay. So here, we can see the difference between the two data sets. A comment in QNLB database just have one sentence, while a comment in movie review database look like a paragraph. It's more than one sentence. So we base on 3 standard value to evaluate the model. These are the precision, the recall, and the F1 score. So we observe that voting has yielded the best result in 3 value: precision, recall, and F1 score. They are all 0.98 for movie review database. However, with QNLB dataset, RNN has given the best result in 3 value: precision, recall, and F1 score. They nearly 0.72. So turn to the final part. This is the conclusion. So all we want to say that we do not have the best tool for any database. So let's apply the suitable one. And that's complete my presentation. Thank you for your attention. So now, if you have any questions, please.
Hi, thank you. Is anybody having, if somebody has questions, please try to raise hand if you can. Can you raise the hand? The participant list or not? Or just interrupt? Okay, if nobody has a question, I will have a question. In your presentation, you were going really, really fast. So I saw passing by that you had some pre-processing of text in the neural network scheme. And I didn't see that in the other schemes. Do you think that having pre-processing of the text will make a difference? And what parameters did you use, or what type of pre-processing did you make?
So you want me to answer about the pre-processing of the recurrent neural network, right?
No, beforehand, you get the text and then you do some pre-processing of the text.
Yeah.
Is that pre-processing common to all the schemes, and what type of pre-processing are you doing?
The pre-processing here, that means we convert from the word into the number, yeah, to represent for the word occurrent.
Mm-hmm.
Yeah, so that's what you want, or anything else?
Why do you think that the model that gives the best answer is giving best answers? What is your guess feeling about why it's more, it has a higher F value?
Based on the algorithm, they will yield the result like voting. They based on the submodels, so they have more than one result to compare. So they yield the best result for the you can see that they yield the best result for the movie review database with a comment contain more than one sentence, while the RNN framework suitable for the comment with just one sentence.
Mm-hmm. Okay, thank you very much. The first presenter has arrived, so we can give her, we can give this presenter a round of applause and allow the first presenter to introduce herself.
Good evening.
Good evening.
I'm Dr. Iman Aldahan from Baghdad University, and my co-authors with me are Dr. Marwan Abdelhamid and MBA Alia. Our presentation is about, and our project is about minimizing costs of transportation problems using, I don't know if there is any sharing here. Is it?
Yeah, there's a green thing below that's called share screen.
Is it now okay? Are you seeing my?
We are not seeing anything.
Oh, sorry. Oh, sorry. I had a problem, but wait a minute. Maybe I could see it. Do anything? I don't know what's happened. I had.
You have to select.
Yes, I selected this. Yeah. Now share. I'm going to do it. Okay. Is it now okay?
Now it's okay. You're in the middle of the presentation, but it's okay.
Okay, thank you. Thank you very much. I'm sorry. I'm sorry. Anyway, I'll hurry up. Don't worry. Our presentation is about the minimizing costs of transportation problems using the genetic algorithms. First, the abstract, I'm going to tell you about it. The research aims to minimize the total cost and reach an optimal solution in the transportation of gasoline product from the main warehouses in Baghdad Governorate to filling stations. The Ministry of Oil in Iraq has a problem in minimizing the cost of the gasoline transport. So we try to make a new method, so how to minimize these costs. So we are comparing the method of linear programming and using the genetic algorithms. We found out that after the research method that we used, is the data were collected from the oil product distribution company, as it is one of the formations of the Ministry of Oil and responsible for the process of distributing the products and gas in the oil and gas in the country, from gasoline storage depots to filling stations, to achieve the goals and development plans of the Ministry of Oil. Through we have this 6 stations here. It's Al-Muthanna, Al-Mansour, it's not clear here. It's Al-Mansour and Al-Banoug, Al-Idrisi, Al-Khalani. These are the main stations, and these are the costs of the gasoline transportation. The solution is according to the general model of the transportation problem. We are building the special model for the problem of transporting the gasoline product from the main warehouses in Baghdad Governorate to the 6 fuel filling stations, and determining the value of the goal function and restrictions, and then solving the model in 2 ways, and comparing them by relying on the table 1, which I just showed you here. And then this is the model, the mathematical model of the problem, the linear problem, where X is the cost of the transportation. The results that we got, it's the mathematical model was solved by 2 methods. It's the linear programming and the genetic algorithm to minimize the final cost of transporting the gasoline product, and the following was if we the linear programming technique we did first, after applying the mathematical model, by which in the window QSP program, the following results were reached. This is the main table that we reached, that it shows that we reached to the final total cost. It's 1,424,165 dinars by applying the algorithm, applying the linear programming. Second, the genetic algorithm, we applied this on these costs or this process, the mathematical model was applied in the program MATLAB using the genetic algorithm method to try to improve the solution resulting from the linear programming method and to make sure whether there was a better solution or not. And the following results were reached. We had reached about the quantity was 1,424,165. And 157 dinars. We see a slight change in the cost because the problem was a linear one, but if it wasn't a linear one, it will be a big difference in it. Here we can see it's about the cost was minimized to about 15% of the main or the real cost that the Ministry of Oil have. The final discussion is we see that the results proved that the final cost of using the genetic algorithm method is slightly less than the near linear programming method. The result demonstrated the possibility of improving the solution and reaching the optimal solution by repeating the attempts in the technique of the genetic algorithm, and the research discussed two methods of improvement to solve the transportation problem and minimize the cost of transporting the gasoline product to the station and then compare them. I thank you very much, and I hope that everybody understood, and if there is any question, I'll be happy to answer.
Thanks for your presentation. Are there any questions from the audience? There's one person asking in the chat, why use the genetic algorithm to find the optimal solution?
Because it's a very good, it's a modern way to find an optimal solution. And we have tried it in several researches. And we found that it has a good, it's very efficient in finding the optimal solutions in any kind of a process, in minimizing products and finding the most optimal strategy in playing in basketball or anything. You can apply it and you will get a very good, result from it. And if he turns and read about it more, he will find that it is a very good method to find the optimal solution in every process.
Is there another question from the audience? Why do you say it's a difference in cost when there's only the difference between the two algorithms is only 8 dinars?
Yeah, but it is. Yeah, it is. It's very small. You see it, but it's really 15%. 15%. It's in the total real cost that that cost them. The Ministry of Oil here in Baghdad, they don't apply new techniques in putting the costs of the transportation. So they have a big problem. They only depend on experience or estimating things by experience. They don't apply these new techniques, neither linear or algorithm genetics. So this should help them. I hope that.
So you're proposing they use either one or the other?
Yes, I think if they use the algorithm genetics, it's better for them. And we are trying to contact with them and tell them that we have found this, depending on their, they know because we took the data from them. And we have to go and get and tell them the results that we found, so we could repeat it again and again until we find a big, results in it, not a slight one.
Okay, and which one is easier for somebody that doesn't know much about computers or mathematics to set down? Because for you, it's okay. Either both systems are giving more or less the same results. So in order to sell the algorithms? Which do you think it's easier for them to accept?
I think it's, it's neither of them are easy for them because they are not, in operation management. They don't know. I said before that they estimate only on experience. So they need a person in operation management that could, or a statistical person who knows to make forecasting. Forecasting is very important in these places, but they don't use that. So I think if they want to try a way, maybe the linear program will be best for them, not the algorithm, genetics algorithm, because it's a new way and modern, not everybody know it.
Okay, thank you very much.
Thank you very much. Thank you, I appreciate that. Thank you very much.
Okay.
Thank you.
Thank you.
Goodbye.
Okay, bye. Can we
Bye.
go with Daniel? You're the third presenter.
Okay. Yes. Let me share my screen. Okay, can you see the presentation?
Yep.
Great, okay. So I'm going to be discussing my paper, which is called Common Pitfalls When Explaining AI and Why Mechanistic Explanation is a Hard Problem. I have a short disclaimer. I'm speaking here in my own personal capacity, and the opinions here are not my own, are my own, and they do not reflect the views of the National Institutes of Health, the Department of Health and Human Services, or the United States government. Okay, so my paper is a bit more of a position paper and a kind of discussion paper. And I find there's a lot of confusion when people are talking about explainability techniques and interpretability techniques because people have different things in mind. So I like to distinguish three types of explanation that you can use to explain AI systems. The first is what is called conventional explanation, and this is some kind of explanation that reproduces the input-output mappings of the system and is relevant. And this is typically what people have in mind when they are discussing explanation techniques. And the explanation is usually tailored to the end user. So it's in terminology that they can understand. This is very different from a mechanistic explanation, which would be more like a scientific explanation. With a mechanistic explanation, you have to really be faithful to the actual mechanisms inside the AI system. And this can be difficult because systems which have very similar input-output mappings can actually work very differently under the hood. So they can have very different mechanisms. This is very common actually in deep learning. If you train several deep neural networks, the way they may be similar in their input-output, but work very differently. The third level or third type of explanation I call meta-level explanation. And this is explanation of a AI system in terms of how it was built. And in this type of explanation, you don't try to go into the details, but you explain the process by which the AI system was created. So it's kind of analogous to the theory of evolution and how that is used to explain animal behavior. So I think mechanistic explanation is what's really important for building trustworthy AI, because only mechanistic explanation can tell you if a network is going to be able to extrapolate beyond the type of data it was trained on, and whether it can be robust to changes in the input distribution. We find this a lot in the field I work in, which is medical imaging. We want to know how our systems are working, ideally, so we know if we can trust them. So for instance, one thing I work on a lot is segmentation of vertebra in the spine and labeling of these vertebra. So for instance, to label this L1 vertebra, we'd really like to know how the deep learning models do that. And the way a doctor would do it is they would look at these ribs, and then they would look for the lowest rib, and the vertebra right below that is L1. But the way deep learning is doing it may be very different, and it may not be robust to changes in the image. So this is another example just to show other things I work on. This is pancreas segmentation. So we would like to really understand how these systems work. And so there's been an explosion of research in this area of interpretation and explainability. This is a listing of all the papers I found. I haven't read all of these papers, but there are dozens and dozens of different papers and techniques that have been proposed. Some of the most popular here I show in red. So one of the most popular that is saliency mapping techniques. And this is a class of techniques that produce these heat map visualizations. But there's a great paper which is called Sanity Checks for Saliency Maps, and they show that these saliency maps and saliency mapping techniques have a lot of problems. So here they're showing 7 different techniques in these different rows, and what they did was they took a deep neural network and they randomized certain layers. So as you move from left to right here, they are randomizing the weights in these different layers. And what you see is that the outputs of the saliency map techniques do not really change very much. So the takeaway from this is that the saliency mapping techniques seem to really only be telling you about what's going on in the like first layer or first and second layers. So basically they are just showing edge detection. So they're really not as useful as many people think. There's another really great paper by Cynthia Rudin. It's definitely worth reading this paper. One thing that she talks about is how saliency maps can be misleading. So for instance, in this example, you had a deep neural network that was able to classify this image as a Siberian husky. And the saliency map is supposed to help you understand how the network worked. So it shows which regions of the image the network used. But if you look at one of the other outputs, you get a very similar looking map. So this is the saliency map for the output of the image being classified as a transverse flute. And you see it's actually very similar. So it's very hard to actually understand what features are being used here to distinguish this image from as a Siberian husky. So basically the saliency map shows you where the network is looking kind of generally, but it doesn't really tell you which specific features it's using and what it's actually doing. This is another example showing some problems with popular interpretability techniques. Some of these techniques are very sensitive to noise, so that's another thing to be aware of. So now I want to talk about double descent, and this is sort of one of the main contributions of my paper, is to make the connection between double descent and explainability. So the double descent is a newly discovered phenomenon where, and it explains several things that people have noticed. So people have noticed these networks have 10 to 100 times more parameters than data points, but they don't overfit. So double descent helps explain this. This, for those who are not familiar with double descent, this is a diagram showing the double descent phenomena. So if on the x-axis here, we have the width of the network, which is proportional to the number of parameters. And on the y-axis, we have the training error and the test error. So initially, the training error, the test error goes down as you increase the number of parameters, and then it bottoms out and it starts to go back up. So that is the classic bias variance trade-off, where you have overfitting, which leads to the test error increasing. But at some point, the test error actually plateaus and then it starts to go down again. And that is the double descent phenomenon. I don't have time to go through these details, but this is a really important phenomenon to really understand how deep neural networks work. And this is a figure from a paper by Hassan, which helps you understand double descent in terms of what they call direct fitting. So if you have a parabolic function and you have some data with noise, and then you try to fit it with a model with different numbers of parameters, if you add too many parameters, you get the overfitting, right? But at some point, when you add more and more parameters, it will actually turn into what they call direct fitting, which is where you have a line basically interpolating through these points. And it's doing it in sort of a piecewise linear way. So you don't have this overshoot and undershoot. And this is what happens when you have a very large model with millions of parameters, is you get this direct fitting. So there's some interesting observations you can make here. The direct fitting is local. And
sorry to interrupt. You just have 1 minute left.
Yeah, I know I'm going a little slower than I should, but this is local. So I argue this is very hard to understand. Then I bring in the idea of the self-explaining AI, which is where you have an additional network that provides self-explanation. I also discuss the importance of uncertainty quantification. I think all neural nets should have an additional output giving the uncertainty. And then I discuss this concept of applicability domain analysis, which is essentially having an alarm system. So when the network is trying to perform outside of its domain, it provides a warning. So tying this all together, this is a network which has these different outputs that provide additional information. So the basic argument is that interpretability is really hard. So a better idea is to use, or a different approach is to use this self-explanation to have the network generate its own explanation for its decision, and then also have the uncertainty quantification and the applicability domain analysis as additional information. And that will help increase trust in these systems. So again, the main takeaways here are that the current explainability methods can be misleading. I believe the double descent phenomenon suggests that it's going to be very hard to understand these networks. So some ideas you can use to increase trust in AI would be the uncertainty quantification, self-explanation, and the out of distribution detection. And please check out my paper, both the ICICT proceedings and this other paper I have. Thank you.
Thank you, Daniel. Is anybody in the audience having any questions?
I know there's a lot.
Okay, I have a question, because the paper you wrote is you're selling us the idea of constructing a network that will explain itself. How do you think you can build that?
Well, I give I give a very basic example, which is having an additional branch on the network, which provides information on what was how the decision or prediction was made. But it's actually very tricky, because you have to in this extra branch, you have to really make sure it is actually related to the prediction or the decision. So that's where I suggest the idea of using mutual information to make sure that the output from the explanation branch is actually related to the output from the prediction branch. And this is just a very initial idea. I'm sure there's probably a lot more work that could be done.
Okay, someone else has any questions?
Yeah.
Okay, so thank you, Daniel. Thank you very much.
Thank you. Yeah, let me close out my screen share. Here we go. So yes, thanks, and please, if anyone is interested, please feel free to send me an email. We can discuss this more.
Okay, is Tokutaka present?
Yes.
Okay, can you go ahead and put your slides?
I share my screen. It's okay.
Yep. You can put your video, I think.
I'm Tokutaka Hasegawa from Nagoya Institute of Technology in Japan. Today, I'd like to talk about based tagging method for social issues in web articles. First, the background of my research. In recent years, various social issues that threaten sustainability, such as COVID-19, declining birth rate, and aging population in Japan. In order to deal with them, it's necessary for students and government to work together, and social issues are frequently mentioned as the subject in civic tech and hackathons. IT and student government collaborate there. In such situations, it's important to investigate existing activities and background knowledge in order to discuss how to tackle social issues. This research aims to search for articles that show the background of issues that lead to solutions. First, we aim to develop a system that automatically tags social issues to web articles. By tagging to articles about social issues, we can search for articles that similar social issues, facilitate the sharing of issues and solutions, and promote relational consensus building and discussion. Second, we aim to develop an interface that enables exploratory browsing. It's a process of searching for information that leads to a solution by following links. It's important to make it easy to access higher level tags and lower level tags for given tags in order to investigate existing activities and background knowledge. In this study, we focus on the first. Watanabe used DBpedia to obtain ontologies for social issues and used them as tags. The problem with the previous study is the tags for social issues are either completely unrelated or include localized tags such as the name of specific cases. As a result of automatic generation of tags by the support vector machine, the recall is 79.2% and precision is 68.8%. In addition, Mission Forest, a web application to accomplish missions to support collaboration and solve common issues, he was not able to use them because of the small number of tags. Next, reading a corpus of social issues. To solve the problem of unrelated noise in the text of Wikipedia's social issues ontology, we used the hierarchical structure of Wikidata, a linked open data which can be edited by anyone. For each social issue entity in Wikidata, we followed the subclasses using the subclass of property. And the entities that subclass of social issue in Wikidata are defined as social issue tags. We constructed a training corpus for automatic tagging by getting Wikipedia's articles linked to the social issue tags obtained here. Here's an example of a corpus of social issues. This is the Wikipedia page on tsunami earthquake. We extracted pages with links to disaster. One of the social issue tags from Wikipedia link information and got the text from the summary section. In the example, the text is considered to have 3 social issue tags: social problem, disaster, and natural disaster. Next, the algorithm of the automatic social issue tagging method. The system outputs which social issues the inputted text is. In this study, we compared 5 methods. The first one is BERT. We use a pre-training model and tokenizer trained on the Japanese version of Wikipedia to perform fine-tuning. For the SVC, random forest, neighbor base, and k nearest neighbor method, the sentences were vectorized by TF-IDF as features. Next, setting up the task. The corpus of social issues is divided into 3 levels, according to the steps from the social issues entity. The 0 level is binary classification of whether the input text is a social issue or not. And the first level is one directory under the 0 level. The problem of local tags in previous research was solved by limiting the number of subclasses. In the same way, for the second level, we set up tasks. We compared 5 methods using the second level classification under the prime class. The broad classification had the highest accuracy with precision, record, and F-measure. A maximal test has conducted on both and the other hand, the other method. All of them were found to be significantly different at the 1% level. Next, percentage of negative cases in the corpus. We tried to verify the balance of positive, negative examples. Using the second level classification under the crime class. We found that the best balance was the intersection of the record curve and the precision curve in this figure. That is, the ratio of negative cases is 25%. Next, accuracy validation in automatic social issue tagging model. We used the corpus of social issues extracted from Wikipedia and actual web articles by crowdsourcing. In the crowdsourcing process, we asked the users to extract one sentence from web articles that matches the specified social issues tags and collected 3,000 actual web news articles. As an example, the results for the second level crime class are shown here. The average accuracy of F-measure in the social issue corpus is 0.87. The average accuracy of each tagging method in the second level of the social issue corpus was higher than 0.87 for all models. In the classification using web articles, some of the prediction accuracy increased, but the overall accuracy decreased. The accuracy of some other classes with binary classifications remained relatively high. If the number of classes is increased in the future, the accuracy will decrease, as in the case of this crime class. So we need to be careful. Next, discussion. The percentage of correct answers exceeds 0.85 for all levels. So the system can be operated by manually correcting errors. The figure on the right shows the confusion matrix of an actual news article at the first level. It shows most of the sentences are classified as other. This is because we randomly extracted unrelated pages from Wikipedia to create negative cases, but percentage of negative cases should be determined for each classes. In addition, Wikidata includes war crimes as a subclass of crime class, and it's possible that it should also be classified into the war class. Many of the crime classes are classified into the war class or prosecution class. Therefore, the classification model needs to be multi-level.
Sorry to interrupt. Yeah, you've just got 2 minutes left.
Works. In this study, we have built a trending corpus using Wikidata and Wikipedia, and proposed a hierarchical automatic tagging system using BERT. Experimental results show that if measure is 0.85 or higher, all of the second level classifications. If measure is 0.7 for actual web articles. As future works, development of an interface for exploratory browsing, interfacing with a facilitation agent system, sharing data through LOD. Also, we would like to try to use them in a lesson and discussion event. Thank you for listening.
Thank you very much. I was muted, so you couldn't hear me. Is anybody from the audience having any questions? Okay, it's a very interesting research. How do you think people can use the results of your research? We cannot hear you. Maybe you are muted.
The result
Mhm.
of my research.
No, for example, you said that people have to and government have to work together. How can government use the results of your research?
For example, people can use it for supporting discussion.
Mm-hmm. How?
And when people generate solutions, when people generate solutions, they will use our system.
So it's a more advanced searching facility to find solutions to problems, to social issues?
Sorry, I don't quite understand your question.
The thing is, you're classifying articles and you're justifying the idea of classifying web articles to help solve social issues. So I'm asking, how do you plan in the future when it's really working to use it or to provide it to government so that the social issues can be more easily solved?
Previous social issue. Exploratory browsing interface will be developed in the future.
Okay, thank you. Somebody has another question? So please give a round of applause to this presenter and let us continue with the next presenter. He is from Sri Lanka, Rajakaruna. I don't know if it's pronounced like that. Are you there?
Yeah, I'm here. Yeah.
Okay, thank you very much. Did I pronounce it correctly?
No, that's fine actually.
Okay,
Let me
sorry.
set up. It's fine actually.
Okay.
Can I get a quick check whether my presentation is visible?
Yeah, it's very well. You see.
Okay, thank you. So I'm Sakil Rajakarna. I'm from Faculty of Engineering of University of Jaffna from Sri Lanka. And now I'm going to present you my research. So you may be wondering, who are Mumbai Indians and what is this IPL? Let's move on and we'll see. Cricket, we all know cricket, right? IPL is currently the shortest format of cricket at some point. There are more shorter formats, but one of the most popular shortest format of cricket is IPL. And Mumbai Indians is one team related to IPL. In our aims and objectives, what we are targeting is predicting the outcome of an IPL cricket match with a higher accuracy. And what brings us this research is the question: are there any significant factors that can change the outcome of a cricket match? And also, in addition, if a model can predict the outcome of cricket match at two states, that is prior to the match and also in real time, then while the match is in progress. As for the scope and limitations, we are only considering T20 matches that are played in the Indian Premier League. And also we are going to use a classification-based approach. So we are going to predict the winner of the match, not something like predicting the score. And also we're gonna drop out the matches that are affected by Duckworth-Lewis-Stern method. So to quickly introduce what Duckworth-Lewis-Stern method is, it's a method that is used to decide the scores and how the match should go on if the environmental conditions, so such as rain, affects the match. Duckworth-Lewis-Stern method will consider how the match results should be gone. And as for data set, our data set is created by obtaining data from ESPN Cricinfo. And this includes data from matches played between from 2008 to 2019. That includes 756 matches between 14 teams, 33 venues, and 559 players. At the right, you can see a small glimpse of how our data set looks like. Only some of the attributes are included here. As for the methodology, as I have already said, that we went to a classification-based approach. And I must say our data set was organized, but it wasn't in a format to be used for our purpose. So we had to pre-process it. So as for the theory, one process was cleaning the data. So we had to fill the missing data. It was easy for us to fill the missing data because a lot of information about IPL matches is available in the internet. So that was easy for us. And next we had to do some data integration. So some teams change their names during seasons. So we had to track them and change them accordingly. And also we have to find what attributes of our data set had a low dedication towards the outcome of a match. And we had to remove those details also. And also for the data transformation, we had to normalize data because the data set was trained in various ways across attributes. And also we had to categorize, we have to process the categorical values to numerical values. And after that, we had to do some visualization. This was to get a good understanding about how the data set is organized and how the data set behaves. So to the left, you can see the pie chart, top pie chart. This is a description of how the toss decision is affecting a particular team to field. So most of the time, the team would go to field rather than batting. And the next is how the percentage a toss winner is going to be a match winner. So it's more than the opposite. And also the middle, you can see some stats about top run scorers in IPL. And to the right, you can see how toss decision prefers according to teams. So what's next? We have to create machine learning models with higher prediction accuracies as per our aim. And we did, but was that enough? No. Why? I'll give a simple answer. They gave low accuracies. So we had to go to an advanced approach. Whoa, what is this? You might be wondering what an alien got to do with IPL or cricket, right? Let me explain. think of a scenario, there's an alien invasion that is happening on Earth, and human race is under the threat of aliens. And day by day, the probability of human race surviving is getting very low. And when you least expect, there comes a savior. For this instance, we'll get a very popular superhero, Batman. Now what happens? Suddenly the percentage of the human race surviving goes high. We are using this same theory in our research. We are building a key player profile. So what's the key player is? A player. He can be a batsman or a bowler. At any given state of the match, a key player can favor his team towards the win probability of a match. So if a match is at the last state of the game, if there are more runs to be scored at the last over, if there comes a batsman who is a very good scorer, the chances of that team winning is going to be high when compared to a batsman with low stats come to the crease. Same goes for bowler. So we are tracking that as a KPI profile. Here we can see Lasith Malinga to the left and Virat Kohli to the right. And here are just example of how we are tracking their statistics. And also, in addition to that, we are modeling the data. We are considering 3 states for each match. Number 1, prior to the match. So that is before the matches happen, or it can be continued after the toss is being played and not before the match is started. So prior to that attributes, here are some attributes we are considering. And the next one is first team batting period. So here at the batting period, we are considering attributes like striker. So what batsman will be playing at the crease, and non-striker, the batsman at the other end, and also bowler performance. In addition, we are counting and considering the over and inning. The next would be second team batting period. Attributes will be same as first team batting period, but here we have some additional features. So the second team batting is called as they are chasing. So they have number of wickets they have to keep in order to win. If all the wickets goes, they will lose the game, and also they have to chase the target. That means runs to win. So we did a lot of experiments and we engineered a lot of features. Here are the features that gave most towards the outcome of the match. Here we have divided the features into 4 categories. One would be batsman related, that's the first column, and the second column would be bowler related. And the third column is based on how each team has performed in their past matches. So that will be called as past match performance features. And the fourth column, that would be one of the most important columns, are the real-time features. And as for results, for our research, we use 6 machine learning classifiers. And here is how each each classifier performed. Here we can see random forest and multi-layer perceptron got very good accuracies compared to others. And this is the performance time for classifiers. Here we can see MLP, in other words, multi-layer perceptron got some bit of time to train, but the testing time of it was very low when compared to others. And also these stats were specific for a particular machine. I can give them if you ask me later. And here are some confusion metrics for our 6 classifiers. Next, moving on, over by over win prediction. In other words, real-time predictions. In addition to the traditional attributes we considered, here we are considering 2 additional attributes, that is score target and remaining wickets. Here our goal is to predict whether the batting team has a win probability of winning or not. Now let's take a look at a use case. This is a match played between Mumbai Indians and Chennai Super Kings at the final of IPL 2019. So next I'll show you how our model gives the output in a table wise. So this is how our model interprets the data and gives the output. So at the rightmost column, you will see prediction. So that is the probability for each over. The model will predict the win probability for the first batting team as for our model. So this is the we are finding the binary logistic probability of first batting team winning a match. And here we are displaying how the prediction will vary through the match. So let me explain you this graph briefly. To the left, you will see runs per over. So that is how many runs scored per each over. And to the rightmost axis, that shows the win probability of Mumbai Indians. So actually, this is the win probability of the first batting team. It varies from 0 to 1. And at the bottom, you will see innings and over. That means if we get one example, this 1 and 5 means first innings, 5th over. So it goes so and so forth. And this scatter plot shows how the win probability varies for the first batting team throughout the match. And
sorry to interrupt. You've just got 2 minutes left.
Okay, thank you. As for the result of the match, Mumbai Indians was losing the match all the time, and suddenly in the last over, the match turned upside down, and Mumbai Indians managed to win. And moving on, use case 2. If you have any questions regarding the graph, you can ask me in the Q&A session. And for the use case 2, this is a match between Delhi Daredevils versus Rising Pune Supergiant. This was the 9th match of IPL 2017. This is the same procedure. Here we can see the win probability of the first batting team goes high and high. And at the moment of innings changing, it goes down. That's because even how the first batting team scored many runs at the start of the next innings, the win probability goes down because a new team has come, then the new team has more wickets and they have more good batsmen. That's why the model prediction winning probability goes down or something like that. And as for potential research, we can consider the environment condition towards the outcome of the game. So pitch conditions and things like that affect the outcome of the match mostly. And also we haven't considered Duckworth Lewis affected matches, and it can also be considered in a way. And also using crowd opinions on social media when a match is going on could be very efficient and towards predicting the outcome of the match. And also using data related to a physical audience at a particular venue can also be used as input data for the model. And as for the conclusions, we have predicted IPL matching probability accurately using past data. And we have done a real-time analysis, that is, over by over, to predict win probability at a given time. And also, we have used a key player-based approach to find sudden changes that can affect the outcome of a game. And also, we model the data into 3 states, that is, prior to the match, as I have already said, prior to the match, first team batting period, and the second team batting period. And that concludes my presentation. Thank you for listening.
Thank you very much. It's very interesting. It's a pity I don't know how to play cricket, but so I can understand this very well. Cricket is pretty similar to baseball or totally different. The thing is, I was trying to find the similarities with football, but it's very, very far-fetched, I think. Can you use your model to try to easily model other sports?
It would be easy to model sports like baseball. So something like the scoring system is a little bit similar to cricket, but when we consider about the game like football, the score systems and the rules differ. So it's a little bit difficult to use the same model. We have to do some modifications to achieve that.
Yeah, in cricket, do many synergies apply? For example, in football, you can have 2 very bad, well, not very bad, but regular football players that play together very, very well. And for example, 2 excellent football players that when set together, they fight for the ball and try to make the goals, and they don't collaborate. Is that the same in cricket?
Yeah, it's in cricket in this way. So in cricket, there's a thing called partnership. So at the crease. So at one time, two batsmen will be playing. So the two batsmen need to have some synergy to keep their wickets, to score runs and keep the match going on in favor of their team. So something like that, it's possible in cricket, yes.
Yeah, and how do you model that in your system?
So basically, here we are considering striker and non-striker. So so striker and non-striker will have good scores. The model will detect whether they are getting out recently or how closely they are going to play. So if we consider two batsmen, so and it will consider that one and give the most appropriate prediction. It'll be a little bit hard, but up to some extent it can be done.
Okay, thank you. Is there any more questions in the audience? No more questions? Yeah.
And
Go
I
ahead.
also sorry to interrupt. And I also like to mention my team, my research partner, and also my mentors, Dr. Rajitha and Dr. Kaneshwaran and Ms. Madhurantaka, who helped me to make this research a great success. That's all from me.
Thank you very much. A round of applause, and let us allow the following presenter to introduce himself. It's Akira.
Sure. Yeah. Sharing my slide. Yeah.
We are not seeing it.
No.
Still.
Yeah.
Okay.
Yeah. I'm sorry. Yeah. Yeah. No. I'm sorry. And I'm sorry. In the system problem. Yeah. No. I'm sorry. Yeah. All right.
It is
No,
not,
yeah.
it's not in presenting mode.
Yes,
No.
yeah, I'm sorry. Yeah, and I'm sorry. Yes, and I study my research. I present my research. Thank you, Chair. I'll talk about methods for extracting cases relevant to social issues from web articles to facilitate public debates. Firstly, I want to introduce the background. Many problems have emerged that threaten the sustainability of global societies, such as climate change and COVID-19. To address these problems, Japanese students need to actively participate in public debates and work together to devise solutions. However, it is difficult for Japanese students to actively participate in public debates because they often lack sufficient background information about social issues and their possible solutions. So our aim is to provide information relevant to social issues and solutions in debates. For this purpose, we have developed the Mission Forest. Mission Forest is a web application to openly publish an activity to solve a social issue and subtasks how to achieve it. We call the goal of social activities as missions. The users of Mission Forest can structure their mission as a hierarchical tree as shown in this figure and selectively make it publish as a linked open data. But it has a limitation that missions aimed by others than the users cannot be collected. Therefore, in this paper, we aim to automatically extract social issues, solutions, and missions from web articles. Our aim is to provide information relevant to social issues and solutions in debates. So I think that there is two tasks. Firstly, we need to share actual cases related to social issues and solutions. Generally, we need to automatically extract social issues and solutions from Japanese web articles. And firstly, I want to talk about sharing actual cases related to social issues and solutions. Our goal is to provide information to promote Japanese citizen collaboration. Elements we provide is as follows. We aim to share the 5 statements to promote citizen collaboration. The description of social issue, geographical region in which the social issue occurs, people affected by the social issue, and description of mission or activity, people working on the mission or activity. Yeah, this is an example of annotation. Areas surrounded by the orange, with more than 1 million people estimated to be hikikomori, it has become urgent to support such people who are unable to reach out and have fallen into social isolation, shows mission social issue. Areas surrounded by the red, the national government, Saga Prefecture and Saga City, shows a geographical region. Our final objective is to share such information. We annotated web article on the basis of web annotation ontology standardized by the W3C. Using the web annotation ontology, a new URL can be assigned to a piece of text in a web article, and by describing the attributes of the URL in RDF, it is possible to link the URL to other resources such as Wikidata. And we think that this data can be utilized. We have defined CRSI cases related to social issues ontology to share the extracting information from the web. It is essential for promoting citizen collaboration by following this ontology and publishing the data as linked open data, but it will be possible to explore the actual cases related to social issues. And web annotation ontology enables us to deal with the relationship between original website and annotation. Here's an example of data constructed using the CRSI ontology. We annotate hikikomori are increasing in recent years in the web article written about social withdrawal. By linking the annotation URLs to Wikidata resources, it is possible to recommend other related to social issues. Next, I want to talk about mechanism for extracting social issues and solutions from Japanese web articles. Our purpose is to build a corpus for precisely extraction information related to social issues using supervised learning. For this purpose, we built a training corpus using crowdsourcing service. We first retrieved 135 Japanese web articles published on social issues. Then we asked crowd workers to extract up to 3 statements from web articles to build a corpus. This is the annotation content. In addition to the information for promoting citizen collaboration introduced in the previous slide, we also asked the crowd workers to answer the confidence, taking into account the difference of annotators' interpretation. Yeah, this is corpus statistics. The average length of sentence in all articles was 45.72 characters, and average class was 40.75. As you can see, right table, the length of social issues and mission or activity were similar to those of sentences. Next, we computed the coefficient. The mean of agreement at the sentence level was greater than 0.4 for social issue. This is moderate agreement. The mean of agreement for mission or activity was greater than 0.3, and this is fair agreement. Yeah, in the study, we tried to extract the social issue and mission or activity at the sentence level. And by fine-tuning Albert natural language model, pre-trained model, we can extract social issues and missions or activity. And we explored two effects. First, the effect of corpus used of pre-trained model. Next, the effect of the input representation. Firstly, we describe the effects of the corpus used pre-trained model. Because the dataset consists of web articles published on social issues and solutions, we expect that using the model pre-trained on the Japanese business news corpus will be more accurate. So we prepared two models, one pre-trained on a Japanese business news corpus and one pre-trained on Japanese Wikipedia datasets. Next, we describe the effect of input representation. Since sentences in web articles are also important for contextual information, we propose the input representation that considers the context around the current sentence. For comparison, we have prepared two input representations. One is to arrange the sentence to be classified, and the other is to arrange the preceding sentence in order to the appearance centered on the current sentence to be classified. And this is experiment setup. This result is a little bit different from our paper because we tried the experiment. Compared with the models pre-trained on the Wikipedia, the models pre-trained on Japanese business corpus attained a higher F1 score on all input representations. And the model pre-trained on the business news corpus and using the contextual method as input representations attained the higher F1 score 0.52, but however, a precision of 0.52 doesn't seem to be practical, and however, please see the next slide. This is erroneous results. The upper part is that the crowd work considered as a social issue, and the lower part is that automatically extracted as a social issue. In this example, some estimates suggest that 1 in 5 seniors demanded by 2025 is not classified as a social issue by the crowd workers. But this sentence is classified as a social issue by extraction model. There were several cases where estimation model was successful in extracting case sentences that were overlooked by the crowd worker. In order to measure the actual precision, we asked the crowd workers to re-verify whether each sentence extracted as a social issue, mission, or activity from the test data is correct or not. This is re-verification experiment result. For each of the extracted sentences, we asked 3 crowd workers to answer where each sentence is correct or not, along with their confidence level. As a result, precision about social issue is 0.74, and precision about mission or activity is 0.84, and for mission or activity, mission activity, it can be practical data by manually correcting the errors. And this is discussion.
Sorry to interrupt. You've just got 2 minutes left.
Thank you. And the models pre-trained on the business news corpus business article were able to extract contents more accurately than the models pre-trained on the Wikipedia dataset. And extraction results are similar to social issues, mission activities as perceived by people. And for mission activity, it is possible to use them by manually correcting errors. So this is conclusion and future work. We proposed a mechanism for automatically, in my research, we propose a mechanism for automatically collecting cases related to social issues and solutions from web articles. And the highest F1 score was 0.53. It is debatable because crowd workers sometimes miss the correct answers. And the results for the verification shows precision 0.74 for social issue and precision 0.84 for mission or activity. And future work using the annotator's confidence in the annotations, I improve the quality of corpus. Thank you for listening.
Thank you, Akira. Somebody has any questions? Okay, there are no questions, but I have a very interesting question. Since we have two presentations that are trying to find special social issues, and they are both done in Japan, what did you learn from Tokutaka presentation that can be used to improve your research, or are they very similar or totally different? How can you compare both research approaches?
At Tokutako's research and my research are similar, but in Tokutako research, using the Wikipedia and Wikidata datasets and the information extracting the information from Wikipedia and Wikidata using Wikidata's theoretical Wikidata but my research extracts from web article such like Google News and Twitter, Facebook, this is the different. This is different point. Is it okay?
Yeah, and did you learn something that can be used within your research?
Use our situation. And my research extraction the data from web article and related association, and the extracted data can be used in the situation which promotes citizen collaboration. For example, in the web discussion like Slack, and recommends extracted information related to social issue to promote the discussion and add knowledge and shortage.
Yeah.
Yes. Yeah.
In fact, we have done some research doing classifications, and using the annotators, confidence in the annotations helps a lot, because even human beings sometimes are not certain about the annotations they do, because human language is sometimes a little bit hard to interpret. So if even for humans it's hard to classify things, imagine for the computer.
Yes. Yeah.
Mm-hmm.
Yeah. So.
Mm-hmm.
Yes. Yes. In the future, yes. Okay. I understand. I understand what you say. Yeah, I agree with you.
Mm-hmm. Okay, thank you very much for your presentation. We are gonna introduce the last presentation. Diha, I don't know how to pronounce that. You are from Indonesia. Are you here?
No, I don't think she's here.
Okay. So maybe we can go on and finish. You have, yeah? Go ahead.
Yeah, after you.
Mm-hmm. Yeah, I was trying to get somebody to do some questions or ask anything. We have a very silent audience. No one? Okay, go ahead.
Just want to sincerely thank our authors for their excellent presentation in this session, and all our participants for being part of the International Congress. I hope this session was informative and knowledgeable as well. Sorry, let me just share this. Yeah. All presenters will be getting their digital certificates through the mail within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 4 to 6 months. I also want to thank our session chair, Gabriella, for chairing the session today. Token of appreciation to the chair on behalf of the team ICICT 2021 and Global Knowledge Research Foundation. Thank you for your valuable presence, Madame.
Thank you very much. And I hope next conference venue will be Costa Rica.
We can only hope.
Yes, not in virtual.
Yeah, exactly. Just quickly before we all go, I just want to request that all of us turn on our camera for a quick snapshot of the virtual camera.
Okay.
Thank you. Is that everyone?
That's everybody?
Okay. Yeah. There we are.
Thank you very much.
Thank you very much all. Have a good night or good day or good afternoon wherever you are.
Okay.
All right.
Thank you very
Bye
much.
to all. Bye.
Bye to everybody.
Thank you, madam.
Thank you.